Broadcast is now starting. All attendees are in listen-only mode.
Hey everybody, this is Derek with eapprentice.net. Thank you for joining us today. We do appreciate your time. Today's presentation is going to be on slowing your feed rates when you are machining in tight areas like corners in pockets. So a lot of this can be handled with look ahead if you have a modern controller. But a lot of people don't realize that you can actually control that from within Mastercam. So Micah is going to give us a presentation today on that subject, and we're backed up. Mike Witten will be joining us, and Jay Kramer will be joining us. Both of these guys helped put together the presentations, both very experienced, and they'll be joining us a little bit later for the Q&A. So I'd like to take just one moment just to do a quick commercial for eApprentice. If you're not familiar with us, we are your CNC training resource. We do online training. We have live courses and recorded courses. Our current live course is Mastercam 101 with Jay Kramer, and we have a new course starting June 1st, which is Mastercam Post Processing 101 with Colin Gilchrist. We do receive a lot of corporate inquiries, so if you think your company may be interested in investing in your training, please share that with us by contacting Dan at eapprentice.net. So that's it for me, folks. I'm going to go ahead and switch over to Micah, and we will begin today's presentation. Hey, Micah, are you there?
I'm here.
Okay,
Hi
so
guys, how's it going?
it's going well, and just waiting for your screen. There we go. We're live.
Great. Um, so as Derek said, today we'll be talking about several ways to adjust the feed rate of your CNC machine to accommodate the corners of your part. This was something I had never really thought about before Mike suggested it for a webinar. CNC machines are well known for their accuracy and speed, but when asked to change direction quickly, like going around a sharp corner, the accuracy can drop off noticeably due to the momentum of the machine in one direction. Think of it this way. If you're driving down a country road at 60 miles an hour, you'll need to slow down for turns. A gentle curve may not require you to slow down at all, while a sharp curve, such as turning onto this side road, will require a much slower speed than 60 miles an hour. The same concept applies when manufacturing parts, especially for older CNC machines that may not have a look-ahead type of feature. If you're using a new cutter capable of high-speed feed rates, you'll cut material just fine, but lose accuracy going around corners because the machine is moving too fast and cannot change direction at the programmed speeds. Those with newer machining centers with high-speed capability probably have a feature built in called Look Ahead. Look Ahead will adjust the feed rate while moving around corners to help account for the inertia of the machine table since there isn't any one way to use all the time. We'll use this simple rectangle with radiused corners as a demonstration for the different methods. I've already programmed a simple contouring toolpath with roughing and finishing pass. Let's backplot. First, the tool rapids over, and then it plunges in at a feed rate of 50 inches a minute. Once at the proper depth, it feeds at 100 inches a minute, all the way around the part. Lead in straight sections and even the radiused corners. With an older machine especially, it will be difficult for it to maintain accuracy while trying to cut the arcs at full speed. If the goal is to have a good-looking part, then that's not a problem. But if we need to hold tight tolerances, this issue could leave us wondering just why parts won't fit together. While we can simply change the feed rate in the toolpath editor, after posting this operation. This can be tedious and cause errors if we're not extremely careful while editing. One easy way to change the speed for corners is to manually select pieces of geometry and specify a slower feed rate using the change at point method. To use the change at point method, open the geometry options in the toolpath, right-click on the chain you used to create the toolpath, and select Change at Point. The same rules for chaining geometry apply here. Each piece of geometry has two ends, so we'll need to select nearer to the end of the geometry we would like to change at. I'll select near the beginning of the first arc to select a point to change at, and pop up the Change at Point dialog box. Change at point is for more than just changing feed rate. We can change cutter comp, depth, spindle speed, and even add in canned text for specific machine functions, or specific functions in the machine controller, like turning on the chip auger. Today, we'll change the feed rate. Check the feed rate box and add in a new feed rate of 35 inches a minute. When the toolpath gets to this corner, it will slow down to 35 inches a minute to go around it, which should be slow enough that the machine can maintain accuracy. Click OK to exit, hit Escape to exit the change at point function, and regenerate the toolpath. Before we continue, let's add in a warning in the toolpath comment for future users to warn them that there is a change in the feed rate, since it's not obvious just looking at the toolpath. Now when we backplot it, you'll see the tool wrap it into position, plunge at 50 inches a minute, start to feed at 100 inches a minute, and then at the first corner, it switches to 35 inches a minute. However, if you notice, every move afterwards is also at 35 inches a minute. We'll need to add in another change at point to get the tool moving at speed for the straight section. Reopen the geometry options, right-click on the chain we used to create the toolpath, and select Change at Point. Select the beginning of the straight line and set the feed rate back to 100 inches a minute. Hit Escape to exit the Change at Point function and regenerate the toolpath. Now when we backplot, the cutter rapids over to the start point, plunges at 50 inches a minute, feeds at 100 inches a minute, gets to the corner, slows down to 35 inches a minute, and then once it's done with the corner, speeds back up to 100 inches a minute. As a bonus, it will do this for both the roughing pass and the finishing pass, and then bumps back up to 100. However, it won't do this for all the corners, just the corners that we specify to change at point. While this works well when there's only one or two sharp corners, for more complex parts, this can cause a real nightmare, especially if there's even a minor change later on. A far more accurate and easier way to change feed rates for corners is to use the cornering acceleration function in the machine parameters. Open the Files tab in the Machine Properties. Click the exclamation point to edit the Machine Definition Manager. Edit the General Machine Parameters. Click on the Machine Dynamics tab, and then click the Cornering Acceleration button. The cornering acceleration dialog box contains 3 fields to help calculate the amount of g-force the machine can cope with and still cut accurately. If you have the time, then you can use this along with a circular toolpath to figure out just what sort of g-loads your machine can. As a general rule of thumb, older machines can handle between 3 and 5 thousandths of a g and still produce accurate parts. If we enter 3 thousandths in the cornering acceleration box and enter 0.5 in the test diameter box, and this never quite works right for me, and then click in the feed rate at test diameter, then we get a feed rate of just over 32 inches a minute. We can use this value with the change at point method, or we can apply it to the whole toolpath using ArcAdjust. Click OK to exit, and then click on the Tool Settings page and check the Adjust Feed on ArcMove box. We can set a minimum feed rate for arcs in the box below to make sure the machine doesn't grind to a stop on very small arcs. We'll need to rechain the geometry. That gets rid of that change at point, and then regenerate the operation. Similar to change at point, it's a good idea to add in an operation comment to warn future users. Now when we backplot it, we can see the effects of ArcAdjust. The tool rapids into position, plunges at 50 inches a minute, feeds in at 100 inches a minute, and then slows down to 5 inches a minute to blend onto the part. The lead-in arc is quite tight, so that's why it is slowed down to the minimum feed rate. Next, the feed rate bumps back up to 100 inches a minute, and then slows down to 54 inches a minute to go around the corner, before speeding back up again to 100 inches a minute for the straight. Another nice feature of ArcAdjust happens on the finishing pass. Here we see the feed rate drops at the corner to 50 inches a minute, compared to the 54 inches a minute that it did on the roughing pass. And that's because it's cutting a slightly smaller arc on this finishing pass than it did on the roughing pass. ArcAdjust isn't a really great solution though. Use the pocket toolpath on this part. I'll go ahead and chain the geometry, and I'll keep most of my defaults, but I'll change the roughing method to parallel spiral, clean corners, to introduce some arcs into this, and turn off depth cuts. Now when we backplot the toolpath, you'll see it rapid into position. Oh, you know what? I didn't change my feed rates. Hang on just a sec. So our feed rate of 100 inches a minute, a plunge rate of 50 inches a minute, and a spindle speed of 8,000 RPM. So now regenerate that and backplot. So it'll wrap it over. It'll plunge. Oh no, now I'm backplotting both. There we go. Backplotting the pocket. So we'll see it wrap it over, plunge at 50 inches a minute, but because it's set up with a helical entry, it should be moving at the minimum feed rate of 5 inches a minute, which it didn't, which it did earlier when I practiced this. Well, you can see it's adjusting the feed rate. Wonder, let's go in here and look at the machine definition. Maybe it reset itself inadvertently. Oh, it's got the cornering acceleration still set to 3 thousandths of a G. And I should have, oops, arc adjust on feed move. Huh. So when I did this, yeah, before this would slow down to 5 inches a minute to feed in the arcs, and for whatever reason now it's feeding at 77 inches a minute for the arcs. But if it doesn't, you don't want your boss to walk by and see the mill not moving, because if it's moving at 5 inches a minute, it just looks like it's sitting still, and he'll go ballistic if that happens. We'll need to turn arc adjust off for the pocket toolpath, but keep it on for our contour toolpath. So to do that, we'll select the contour operation and lock it. Then we'll reopen the tool settings page, turn adjust feed on arc move, uncheck that box, exit out of this, and regenerate the toolpath. So now when we backplot it, we'll see it wrap it into position, plunge at 50 inches a minute, feed 100 inches a minute. And this is fine for the roughing operation, since we don't need a great deal of accuracy. So obviously, arc adjust isn't really ideal, since it still takes a fair amount of work to get work. The last way we'll show to adjust arc feed rates is by using high feed machining. High feed machining works very similarly to arc adjust. It uses the same cornering acceleration parameters we set up before in the machine dynamics parameters. However, high feed machining has additional options that allow users to better customize the results, especially for roughing toolpaths. I've set up a similar file that has multiple toolpaths set up to machine the part. Set up roughing toolpaths for the outside and inside of the part that leave 10 thousandths stock, as well as 2 separate finishing toolpaths. The pocket finishing toolpath has been set up with a 1/4-inch end mill. Actually, both finishing toolpaths have been set up with a 1/4-inch end mill, which will force it to slow the feed rate around the interior corners and these tight exterior corners when the tool moves in an arc. Currently, the toolpaths are all set up to feed at 100 inches a minute. We'll apply the high feed function to the 2 finishing toolpaths. Select both toolpaths by holding down the Shift key after selecting the first toolpath, and click the high feed button. If we use the roughing and finishing option, Mastercam would actually calculate volume of material based off the end mill, toolpath, and stock definitions to help create an efficient toolpath, similar to a 2D high-speed toolpath. Since we're just applying this to finishing passes to create more accurate finishing button checked, and click OK. On the ribbon bar, we can step through the modified toolpath, seeing what G-code is being used and what feed rate is being employed. So here's our G-code, here's our XYZ position, and here's our feed rate. Click the play button to see the results of the optimized operation. In this case, it has added time, so before it was 25 seconds, and now it's 31 seconds. But it is well worth a few extra seconds to get more accurate parts in the end. High feed automatically locks the operations for us, but it will be up to the programmer to add a note in the comment section to alert future users as to why the operation is locked. Now when we backplot these operations, we can see the feed rate of 100 inches a minute in the two roughing operations. Select all those. So we can see feed rates of 100 inches a minute. Go ahead and forward that to the finishing operations. And then we can see a constantly changing feed rate down here for the finishing operations. So it actually accelerates out of the corner, goes down the straightaway at a high rate of feed, and then slows itself down as it gets into the corner. So here we're not quite to the corner, and then in the corner, slows itself to about 40 inches a minute, and then speeds itself back up. Mastercam has made a smooth, accurate path even older machines without look-ahead can follow. It may not match the abilities of newer high-speed machines, but it does give shops with older machines a chance to compete for accuracy on a cost and time per part basis. Are there any questions?
Hey, Micah, it's Derek.
Hey, Micah.
Oh,
Hey,
and that's
Jay.
Jay. Hey, Jay.
Well, that's. I just want to throw a thought in there for Micah real quick.
Yeah.
Micah, actually get out of the back plot for a minute for me.
Okay.
And I want to just show you a little quick, simple tool for further reference for yourself. Because you were going through and you had multiple operations, and you were going, I'm trying to backplot just one. And as you went, it was like there was multiple selected. So when you hit the backplot button at the top, it automatically selected everything that was checked. So in this case, like you're showing now. So now go ahead and back out of that again. And what I want you to do is I want you to be,
Okay.
so they're all highlighted. I want you to backplot the
Yeah.
second one for me, but hold on. Where it says toolpath on the second operation, put your mouse over that. I want you to left click on it.
Okay. And that gets just to the pocket toolpath.
Just for that one for backplot.
Yeah.
So you can do a single operation.
Yeah, well, oh, no, I mean, I really did mean to backplot all those operations at the end. It's just...
Oh, no, on this one, fine,
Yeah.
but on the other file,
little...
you were going through and you were trying to use the button at the top, so you were doing that. Now, if you go back out of this, and if you probably don't have stock set up for verify, but if you did, if you right-click on the same option that I just talked about,
Mm-hmm. Oh, look at that.
It goes into verify. So you can go after a single operation at any time that you'd like by just going and clicking left click on toolpath for backplot, right click for verify on any single operation. So just in case you wanted to do one when you're doing the presentation. Fantastic presentation like normal from you. I'm always amazed. Thank you very much, by the way.
Oh, thank you.
Excellent. Thanks for stepping in there, Jay. I was actually waiting for a train to pass, hoping I wouldn't have to go on mic. And not only did you give us good information there, but you saved me from having to have that train on mic. So I agree. Excellent presentation there, Micah, as well. And we're trying to keep up with you working here in the background. It's been a couple of weeks since we all kind of got together and tried to shake out the content for this information. It can be a super complicated set of features to get this arc slowdown to work correctly. So let's work through. Thanks, Jay, for stepping in and helping us in the background. And Mike Whitten is also out there. And certainly we need you guys to help us on this. With some of these, these expert commentators in the background definitely help Micah and I as we move through this. So we got some questions coming in. Let's see if we can hit some questions, and then Jay and Mike, you guys feel free to jump in at any time with answering questions or just with your own comments. So there's one I had answered online from Jean. That's cool. I'm working with Mastercam for 8 years and always changed the feed rates by hand. So certainly John was very happy to have this presentation today. He's got a new way to do it. Let's see, we've got a question here coming in from Caesar. I have several older machines that do the opposite. When running dynamic core mill, high-speed toolpaths for roughing feed rate slows down so much at arcs and back feed rate. Is there a way to overwrite the look ahead of the machine and make lines and arcs run at the same feed rate without slowing down? I see. So you're trying to do the opposite of that. Probably you need to make some adjustments there so it doesn't slow down so much in the arcs. So out there, Jay or Mike, do you have a comment there on Caesar's question? I think it's specifically for dynamic core mill.
It could be that the look ahead or high-speed software on the machine is slowing the machine down automatically.
Good point, Mike. So thanks for jumping in there, Mike.
Or it could be that the toolpath is not filtered, so it can't process the small moves. It's one of those two things.
Okay. Now,
right, that's what I was thinking about was the older machine, because a lot of the older machines don't have a good look ahead. So when you start getting over 60 inches a minute and there's small data, it starts to actually choke. In this case, the machine might have some kind of look ahead, a different type of look ahead. Sounds like you're saying, Mike, the same thought. So what it's doing is it just, instead of just choking where it stutters, it's actually just slowing it down. Would you agree on that?
Yes. A big key in the older machines, of course, is to, on the 2D milling like that, is to filter it so it filter it pretty loose when you're roughing and make sure you have the XY arcs turned on.
Okay, well, can you walk Micah through that? Maybe he can just show that on the screen. Pick a toolpath there, because that should work even with not just in a dynamic core. That would work on a regular pocket toolpath. Would you agree?
Well, you could open up the pocket toolpath. I usually have the filter turned on that too, just in case your profile has splines in there. And just go into your, right there. You can turn your ratio usually about 2:1, depending. And you know your total tolerance should be relative to how much stock you're leaving and the machine you're running and stuff like that. So let's say you were roughing leaving 20, it would be definitely okay to have 3-4 thousandths tolerance there, at least 2. And you can play with the filter ratio so that you get more arcs and smaller amounts of code. It's really machine dependent and control dependent that makes a big difference. But if it's just an older machine without any look ahead at all, then you're usually always better to have the smallest amount of code with the most arcs that you can get. Right, Jay?
Yep. Does make a difference. The machine moves a lot smoother, and we'll keep up with the speeds a lot better.
Right.
Yes, I've actually had extremely good luck with Mastercam and filtering. I mean, I've been using the software since the beginning of version 8, and I've just never had a problem with it filtering.
Agreed.
So I would say feel free to filter away. I have it set up in my defaults, where my filter's turned on 2:1 at 1,000th on every toolpath, all the 2D toolpaths.
Okay, well, Mike, I'm going to have to call you on that. If you're going to say it's turned on in your defaults, then we're going to have to show them how to turn it on in your defaults.
Oh, okay. There. Now you got it. See what happens, Mike? Now we can't say anything anymore. Derek's going to take us to the mat.
Okay. Yeah, we've got 30 minutes left, guys. Feel free. So, should we do a quick walkthrough setting that up in the operation defaults? There we go. So go ahead, Micah.
Yep.
And
so it's yeah, I actually did a webinar on this, I don't know, months ago now. But what we can do is click the exclamation point, and this will open up our operation defaults window here. And you notice it looks an awful lot like our toolpaths menu. So for our pocket here, we can expand and click on the parameters, and then we can go ahead and set up the filter ratio and set it to 1,000th. We'll click OK, and click OK again, and click OK a third time. So now let me go ahead and turn all these paths off. We'll drop this guy down there. Now if we do Pocket Toolpath
Yeah.
and click on the arc filter tolerance, it's already turned on, and
Right. You have to
it must
reload
have
the
pulled
default.
that from the earlier operation.
Right. So
Oh,
if you
okay.
hit one of the top buttons in there and reload the defaults, it should load it.
Yep, there it is. So a filter ratio of 2 to 1 and a tolerance of 1,000th.
All
Right.
right. And in case you guys didn't see that, Micah just clicked on that reload defaults icon at the top of the sheet there in his operation parameters. So there you go, guys. 2 for the price of 1. So filter ratio, just set it in your defaults. It could be a little bit confusing to explain and understand, but if you just set your filter ratio to 2 to 1, you're going to get a pretty good output. You're going to notice a lot shorter code right away, and that should help smooth out the moves for your CNC
Yeah.
machine.
One thing to think of is one thing to really watch out for, which is definitely somewhat related, is that if you're just doing 2D milling and you have splines or dirty 2D geometry of some sort where there's a lot of small moves, this can help, or will usually always help. It will always help, but either way, you need to be real careful with cutter comp, because there's going to be certain situations where the arcs are so small, the moves are so small, regardless of whether it's filtered or not, you would not want to use cutter comp, or you'd have to do some extra work on the filtering and geometry cleanup.
Okay, so that's something to watch for. So if you are experiencing alarms on your machine, I'm guessing, Mike, the alarm would be that there was not enough of a move for the cutter comp to activate itself. Is that what you're getting at?
Yeah, it could be lots of things, but yeah, usually that's it.
Hmm. Okay,
You
so
know,
something to be aware of there. But for the most part, Mike, would you say that you usually leave your filter turned on?
believe it or not, I have the way he's got that on his right now, the way Micah has the filter turned on right now, and in this screenshot, I've had it like that probably since version 8 or the middle of version 8, and I've never had a problem. Never. And that's just
Perfect.
how it's always been, and I've never changed it.
Yeah.
It's actually kind of amazing. The only thing I do is, if I have a really small part, really small profile, and there might be some splines in there, I may adjust that total tolerance a little smaller. But generally, if you just have 2D geometry, it's not going to filter it anyway. So it's not going to change the tolerance of your toolpath.
Right.
It's
only
only
going to
going
do
to
it.
use this mainly for roughing and for splines. Is that accurate, Jay? Do you agree with that?
Well, Jay's checked out for a second, but I certainly agree with that. So thank you for that, Mike and Micah. That definitely clarified that situation. And Caesar, if you have a follow-up question, feel free to follow up with that. Let's take a question from Alan. On the high feed option, does it break the corner radii into multiple arcs? You want to take a crack at that, Mike? And the second part of that is also, what is a good starting point for the high feed settings? So really 2 questions there. And I'm almost wanting to guess that on the first on that, does it break the corner radii into multiple arcs? That might depend on your post processor. What do you think, Mike? Looks like we may be having technical difficulties. So bear with us a moment, folks. This is definitely live TV as
I
usual.
set this up by default. It makes good sense because what you're saying, like you say, is that you don't have to worry about if there is splines or not. When you go to change the geometry, if there is, it's already active. And if it doesn't have splines, it's not going to modify or change anything in most
Correct.
cases
Yep,
for you.
exactly. That's
And
why
it
I
can't
think it's
hurt
better
anything.
to change it in your defaults.
Right. And I'm, out of curiosity, I hope a lot of people know the difference when they look at these things. I don't know if you covered that real quickly, was when they look at the create arcs in X and Y, X and Z, and Y and Z, actually what code changes to be able to manipulate that to happen in the machine, being the first one being the X and Y always being G17, the next one being G18, and then G19 being that the machine needs to see the change in plane and they have to lay in that along those planes.
Right. What I usually do, which I think it's personal preference, on my average everyday posts or defaults, I just leave the XZ and the YZ off. I use that for a special situation just because I just think it's easier. And technically, with a good post, you don't need to worry about it, but you know what I mean?
Right.
What's the
Usually,
point
but
of having it
leaving
throw a G18 or G19 in there to make your G code 10 lines shorter once every 3 months?
right,
It's just
because
that.
along that act, yeah, because that's one definition that a lot of people don't realize is that okay, so it's going to do along the X and Z. Literally, the arc has to lay along the X and the Z for it to actually do anything. Because if it's off, say 2 or 3 degrees in X along the X axis coming from say the Z top, it's not gonna change it. It's not gonna output a GO2 or GO3 along with the G18 change.
Oh yeah, definitely. You know.
So like you said, yeah, X and Y, that can happen quite often because you're along your standard top plane.
Yep.
Right.
So I
Okay.
agree.
I think we covered that. Now I was checked out, guys. So my internet took a glitch, but apparently you guys were in good shape and still going on with the conversation. So I think you guys covered the multiple arcs there. And then the second part of that question: what's a good starting point for the high feed settings? Did you guys go over that a little bit?
I don't think that was covered. Mike, you want to come up with
No.
a?
Um, well, it really depends whether you're using it for roughing or just for finishing. It's pretty complicated if you use it for roughing also. What I do usually, um, I'm looking at a document here. Uh, let's see.
Well, when
If
we
you
were
want to
going
switch
over
it to my
this,
screen, I have something on here that we can look at.
Okay.
Or you know what? Actually, Micah, if you open the machine dynamics, that might be easier than switching it to my screen.
so you want me to
So
open the cornering acceleration again?
I know. Actually,
Okay.
this is fine here. One um, one real key point about Mastercam and high feed is that the help is pretty good. I mean, it's really good. So if you hit that question mark there, so we can all see the help. You just it's I guess that would be context sensitive. I guess that's the name. But I would recommend going through all the help on the high feed here. So now if you get out of that, thank you. The feed rate smoothing is not used when the accelerate to smooth feed rates is off. I'd recommend reading that, or you can pull that back up in a little bit here because it's pretty complicated. It gives it additional smoothing, so it really emulates a look ahead function on the machine. The major issue with it though is it'll just make your G code file enormous. So most people don't use it. It's for a special application. The look ahead.
I was just going to ask Mike, would your G code file be enormous because you're changing feed rates on every line?
Right. It's that's the issue.
I see.
if you give me 1 second here, I open the help on my end because it explains it a little bit easier than I can.
Yeah, the help when you go through it, it actually gives you, and they even talk about doing a sample test for for G's and things like that on your machine and stuff like that. So there's a lot of different data. And like Mike's saying, it can get very complicated trying to explain it. I know that sometimes trying to explain that in class too is a very hard one.
Right. Yeah, they go through the whole thing on test cuts. So anyway, and then there's the look ahead. So pretty much the most important ones are the look ahead, the max feed rate change per block, and then the cornering acceleration down there. So the look ahead is how the distance that it breaks the segments into. Because what it has to do is it has to break the toolpath into segments so it can change the feed rate on every segment. That's the issue with it, is it increases the size of your G code, which on most machines, a lot of the newer machines nowadays is not a problem. So that's why it works pretty good. Let's see. So that way, let's say, for example, you're running 200 inches a minute, and now the tool is going to hit a real tight area. It can't just go from 200 inches a minute to 30 inches a minute in one move. It's going to have to accelerate and decelerate. So that's what the look ahead distance is. If you set it to 10%, it's going to break up the segments to 10% of the tool diameter. And the max tool, feed rate change per block is how many, is just as it states there, that's how much it can change it per block. So if you were going 200 inches a minute and you had to go down to, say, 30 inches a minute, you would have, what is that, at least 7 or 8 blocks of code at least. So 8 times 8 blocks of code, 8 segments that were 10% of the tool diameter long. That's what it would do. Mm-hmm. So it would go 200, 180, 160 down until it got to the feed rate required, which was calculated by using the cornering acceleration and quite a few other settings that are in the high feed dialog box.
Right. So now we've just added about you've added about 6 lines of code at this time, right? Just to go at just coming from a straight and slowing down to the corner. It took that straight line that should have been maybe a line or 2 of code, and now might be 8 lines of code, because like you said, as it gets down, it has to start slowing the machine down before it gets to that intersection. It's complicated, but it does work pretty good. It's just everybody has different needs, to be honest. So it just depends what you want. What I do nowadays, fairly often, is I use the high feed on the older machines, but I have it, I guess you could call it juked. So that way it does kind of like an arc adjust thing, except it adjusts it per the cornering acceleration. And it doesn't add, it adds almost 0 lines to the code. It makes the code maybe a few percent bigger, if that. So what I do is I have the recombined segments, that recombines, as it says, it recombines the segments. I have that set to 10%. I have the look ahead set to 10%. And then I change the max feed rate per block to 500. Because usually in a finished application, everything's a compromise in high feed. Because it'll do exactly what you want as long as you can accept a large enough program. So I set the max feed change per block to 500, and the slow to minimum cornering feed rate down here to 179.9. And what that does is it does like an arc adjust. It simulates arc adjust, but works a lot better. Anyhow,
right.
That's about it, I suppose.
Right. Well, thank you for that detailed explanation. This is why we have Mike and Jay on here, uh, because these are the guys who know how it all works. So really appreciate that. Let's see. Moving on to Miroslav. Is it possible to slow down in internal sharp corners in surface operations?
You want to take that, Jay,
I'm
or you want me to go ahead?
Well, go ahead. I mean, if I were
yeah,
answering
because
it,
Mike, what
I
I mean,
I
go ahead.
actually don't think it works in a three-axis surface operation, but it might work in a Z-level operation. I just
Right.
haven't tried it.
No, and and it's my experience. That's where I was going. Is I'm thinking, going, okay, if I ever used it, was it feasible? No, that I know of is on that. But that one, you know what? There may be something, but maybe there's something that we need to check with CNC, because but I mean, I feel pretty safe to say no, it does not, and I think you follow along with the same way, correct, Mike?
Yeah, except I think maybe in Z-level finishing or Z-level roughing it'll work.
Right. So like if you were using surf rough
Right,
surface rough pocket in that
right,
case, where it's literally pretty much almost linear motions
right. I
along
think
that in
yep,
arcs and stuff compared to you're trying to calculate for a speed when it's not a true radius when you're doing 3D coloring, because 3D coloring is actually is usually three axis, yeah, kind of compensate for three axes and what is truthfully a corner radius. So in
right.
this case, that's where I would say no on that.
I would agree.
okay, except for when, as you guys said, it's Z-slice roughing operations. So let's keep this going. Just a comment from Robert. Never saw that before. Thanks for sharing. And then also followed up, thanks with a great job. So I agree, Micah, Mike, and Jay, all three of you guys with a great job. Steve Quinones just said, hi, guys. So, hey, Steve, thanks for
Hey,
joining us.
Steve. Yeah, no kidding.
And for those of you on eMastercam, Steve is hard mill. So another good guy. And I think we'll have to try and
Oh,
recruit him and get him on one of these pretty soon.
his first name is now put out there along with his actual stage
Oh,
name. Uh-oh.
darn, I said that out loud, didn't I?
Yes, you
I
did.
thought I was using my inner voice on that one. Sorry about that, hard mill. Let's keep moving. Jean has a question. Same for circle mill. So do these high feed functions work the same for circle mill?
Yes,
The circle
sure.
mill. I think we're saying specifically the circle mill toolpath, right?
Yes,
Yeah.
they
So
do.
that's a yes. George says, Jay, can you please show that again? Well, we're looking at Micah's screen, George, and it's been probably 20 minutes since you asked that question. So if you could follow up again, we'll try and nail down exactly what you wanted to see. Let's keep going. I have a question from Joel. Are these options available for lathes as well?
Ooh, that I
No.
do not. That I don't know.
No, there is no there's no high speed look ahead for cornering and stuff like that. I know there's some newer functions that are coming that will support a little bit of that transition like that. Actually, I thought I have to do my homework on that one because I think there's actually a path that actually does that. It's inside of X7. I'm in the middle of programming 5-axis right now, but I will look into that and we'll see if we can't put a note or something up in another webinar.
Yeah, and
Apologize
feel
on that right now.
right. And feel free, Joel, to send us a follow-up email. You can send an email to Jay or Derek or Mike or Micah at eapprentice.net, and we will follow up and see if we can solve that for you. So next one was a comment from Alan. Question from Caesar, maybe due to arc filter not being turned on. And I think you're correct there, Alan. We went over that several minutes ago, so I'm a little bit behind on questions here. Um, well, Caesar followed up. Okay, he is filtering the toolpaths. So the other thing, Mike had said is it's possible that it's the high speed function on your machine controller, or that your machine, maybe you need to activate those high feed, or I'm sorry, high speed look ahead controls. I don't know, Jay or Mike, you guys have a comment on that?
Well, I know that some machines in this case do have that option, and like I said, I would check that with your machine builder to see if you. I mean, the best way to do it is do a test. Literally, is to find out from your machine builder how do I turn off that function in my machine. Or in some cases, some machines actually have a code that will activate it and deactivate that.
Hmm.
So you need to find out if there is a code because you might be able to go ahead and do a code that would deactivate that, uh, just hand force that one in with a manual entry or something like that, and then let the system do the rest of it. Let
Right.
Mastercam take care of the rest.
So it
That
could
would be
just
one of
be
my thoughts.
right. It could be that the controller has been set by the manufacturer to hold really tight tolerances, perhaps a tighter tolerance that you need, so it's accelerating and decelerating more than it needs to.
Right,
So
because some of the machines like Matsura's and stuff, I'm sure Mike knows the same thing. Is that we know that there's a couple of different settings for the high speed, being a fine or a heavier type of high speed look ahead and stuff like that. I think that's options. I know that in the Matsura's and I think the Toyotas too. You know what I'm talking about, Mike?
Yeah, it can, like it's kind of like an accuracy setting.
Right. Yeah, it's an accessing along the high speed, so some of those things where they can turn on and turn off when it's activated. So it's not on by default all the time. It's when long as it sees the code, and then it defines the accuracy at the same time as it activates it.
Right, and what one thing that can happen is there are some machines that have it on by default, like the Haas. It's set to medium by default, like in the newer
Yep.
machines.
You can only control it in the machine itself.
It, I think you can control it by like a G187. I've never ran one, but I think that's what it was.
right, but
But
definitely it's machine tool specific. So we recommend Caesar on that
yeah,
one. Get a hold of your applications engineer from your machine tool distributor. They should be able to help you with that. So I'll keep this going, guys. I'm trying to finish here in 6 minutes. So those of you on the West Coast, we can wrap up at lunchtime. So I'll keep this going. I've got a question coming in from Jean. In the circle mill, the tool comes to the center before making a finish pass, and the machine makes a bad move too fast. Can we change the feed in in the same way? Either you guys
No.
recognize that issue, uh, high feed rate with that very first move on a circle mill cut?
Um,
no, I'm
are
not
you talking
sure.
standard circle mill, or you're thinking, or are we looking at five-axis circle mill? Because I was just doing a five-axis circle mill yesterday, and I know that when it transitions to the next one, it's a little bit
Yeah, no.
on the fast
This is
pace.
a standard, just a standard circle mill. John is responding there. Follow up. So it seems like you know how the circle mill,
No,
you set it to start at center and move
right.
out, and looks like he's getting a feed rate that's too fast on that initial move. So I don't think that's a high feed function.
Mm-mm.
I'm not sure. I'm going to say on that one, John, if you want to output a G code, if you want to do a test file, just do a circle mill in a Mastercam file and also output the G code so we can take a look at it. If you send us that file, we'll take a look at it and see if we can help you a little bit more with that one. So send that in to either Jay or Mike or Derek or Micah at eapprentice.net.
Um, I have one quick comment,
Okay.
Derek.
Yeah.
As I think we were speaking about once before, one way to kind of ballpark the feed rate for your machine on Circle Mill is just go into your local copy of the machine and look at your general machine parameters there and your cornering acceleration and set that to what you believe it would be on an older machine. Usually it's going to be, just as Micah said, 0.003 to 0.005. And then type in your radius and have it give you the feed rate. That way you don't have to guess. It's kind of like manual high feed.
Okay, that sounds good, Mike. And I'm sorry, I was
Yeah,
getting a little distracted. I was watching Micah at the same time, and Micah was also showing the override feed rate. On that center mill. So yeah, Jean says okay, he's going to try that. And
yeah,
how's
because
that feed rate looking for your output there, Micah? Did that?
Well, that was 100 inches a minute for the just a regular pass. So if we apply the high feed to that and click OK, oh shoot, apply the high feed for that, click OK, press play. So it bumped up the time quite a bit, 7 seconds there. So now if we back plot it, step through here, here's the plunge. Yeah, it has adjusted the feed rate. So now it's doing the helical entry at 21 inches a minute and feeding out at 29. And it's actually doing a spiral feed out. But I imagine since it's changing the arc feed rate here, that if it was a straight line out to cut the circle, that it would probably change the feed rate there too. So here it's doing 31 inches a minute.
Okay, and then just show that parameter one more time. I know we were
Yes.
kind of getting two solutions to the same problem there.
So I set it up with a feed rate of 100 inches a minute and a plunge rate of 50 inches a minute, and we're cutting a 3/4 inch diameter circle, and I made a roughing pass, and I did one finish pass of 10 thousandths, and when I backplotted it without applying the high feed, it did the whole thing at 100 inches a minute, and then after I applied the high feed and backplot it, it's doing its helical entry at 21 inches a minute, and then as it arcs out, so you can see it spiraling out there, it gets up to 33 inches a minute to cut the actual circle out.
Right. So could you just show that
And then
checkbox one more time there, Micah, the override feed rate?
Oh yeah, so I didn't actually override the feed rate, but it's also got you can override the feed rate
yeah,
for the finish
okay,
pass.
gotcha. I saw you playing with that at first. So okay, well I think we got good answers there, Mike. I'm sorry, I think I interrupted you there. I was watching the screen while I was listening to you. Did you want to follow up, Mike?
Oh, actually, no, but I do have a comment.
Yeah.
The example that Micah just did is perfect as far as an example. It just shows exactly what you could use to slow the feed down on a circle mill using high feed.
Right.
That's exactly what I do all the time.
Perfect. All right. Well, we're a minute away, guys. So let me see if I can go through really quickly. So if let's keep the answers short and sweet, or yes and no. And then Caesar says thanks. Question from Jimmy: what's the difference between 2-to-1 and 1-to-1 filtering?
Micah, would you like to open up a filter dialog there?
Yeah. Oh, shoot. There we go.
It's the ratio. Go to 2-to-1 of the filter tolerance to the cut tolerance. So 2-to-1 is 2 times filter tolerance to the cut tolerance. If you hit the question mark down there, it explains it real well in Mastercam.
Mm-hmm. Right.
Yeah.
And I think fair enough with that since we're low on time. So definitely, Jimmy, hit that help box there. I know that's always a little bit confusing to me as well, but the help is pretty good there. Let's keep this going. Got some comments. Tom, thanks for the information on the filter. He was having the same issue. Mike was asking, can you show the high feed procedure one more time? And I think we've done that one more time since the question was asked, so I'm going to move on. And for those of you on this, I'll get you a copy or a link to the webinar so you can watch it again. Jimmy asking, should you always simplify splines before running Toolpaths?
No, not necessarily.
Okay.
It's Mastercam's designed to cut splines.
Okay.
You know, it just depends what you're doing. You know, it just depends. Okay. Generally, no.
Okay.
See, I look at that as when I look like bringing the difference in. I simplify when I bring IGES files in, because IGES files will actually a lot of times overcomplicate simple lines and arcs a lot of the time and actually create splines at that time. So that's when I suggest that doing the simplify for one thought, where compared to bringing any kind of solid. Go ahead, Mike. I know you're. I
All
hear
I'm
it.
gonna say is I agree with you because yeah, like if it's file dependent and you got splines all over the place when they should be arcs and lines, then yeah, you have to simplify.
Right. So that you could use that basis. I mean, if you want, I call it a golden rule for me is that if I'm going to bring an IGES file in and I have to use that particular file with those, like you said, is that wireframe on it, I simplify, I delete duplicates and then I simplify before I even start going into it. So if I'm going to use any of the wireframe, hopefully I got rid of most of them, because when you bring in a solid and things like that, you'll find that you don't get duplicates. You don't. It minimizes how many splines you'll get. You will always get the minimal amount of splines when pulling in wireframe off of a solid.
Right, and it's good to use screen statistics to do a spline count.
Correct.
Right. And I may be going over the same thing you guys said, but obviously sometimes with some softwares, Pro E can do this a lot where you bring in a file and it makes everything a spline. So when you try to drill a hole, Mastercam doesn't recognize it as a circle. So instead of picking up the center of what looks like a circle on the screen, it actually drills out at the edge what it thinks is an endpoint of a spline. So certainly edit simplify um, would solve that issue. I don't know, Micah, if you want to just quickly click edit and then simplify.
Yeah,
That
because
way,
the Pro E has a thing called flavors. So as they go through flavors on their IGES output, actually if they get the flavor settings, they call it like a flavor settings really, and when it's set just right, it'll be one of the cleanest IGES files that you'll ever get. But if it's not, you start getting issues like you're talking about, including you can have missing surfaces and stuff. And it's now called Creo, by the way.
right.
Right.
Exactly. So, all right. Well, let's keep this going. Henry has a comment. I'm not sure who he's talking about. He says, "Holy crap, Flute Face is here." So,
That would be hard mill.
yeah, and Hardmill actually followed up as if he had already knew that was coming and said, "Just here to heckle." So, okay, fair enough, guys.
Exactly.
Uh, Ben
All
gave
right, I'll
out
talk.
Ben's got a comment. Great job, gentlemen. Thank you. This is a real shout out. Well, thank you, Ben. We also appreciate you spending time with us. Um, Bob has a comment. I think you're referring to HPCC, and it's already been a few minutes since that comment, so I'm not sure at what point we're going back there. I don't know if you guys have a very quick. Anybody have a comment on that? The HPCC.
He's talking about what we mean, Mike. We're talking about where like the certain like Matsuras and things like that. They have different settings for the look ahead for the on that, and the HPCC is that I know of is that configuration. They call it that.
Okay, that would make sense. That was about the right timing. So Henry came back in. Thanks, guys. Good job. Very informative. Thanks to you, Henry. Thanks for being here. It was good seeing you at IMTS. We'll see you there at the next one.
Oh, that's right.
Yeah. Let's see. Kurt is asking, where is the high feed rate switch again? Can you point that out one more time, Micah?
Right there.
Right
So if
there.
you select the toolpath and then click the high feed, it'll apply high feed to that toolpath.
Yeah. Try not to click the stick of dynamite instead, because that will not have the same result.
Well, it asks you first. So
Okay, there you go.
you can click
Permanently
that. Don't
delete
hit yes.
everything? No, that's not what we want to do. Okay, so Jimmy's going to switch from 2 to 1, or from 1 to 1 filtering to 2 to 1. So good stuff. Rick says, I always learn more in 1 hour on eApprentice webinars than in a week full of work. Well, thank you for the kind words there, Rick. We appreciate that. Steve's just he's just laughing his ass off over there. So, and yeah, Henry says, yeah, that was for. I'm sorry, I keep saying that name out loud. That was for Hardmill. So the inside joke for some of you guys, if a lot of these guys are on emastercam.com. And if we're not available on one of our weekly webinars, you can go to emastercam.com at any time, register, go into the industrial forum, and you can ask your Mastercam questions. Now, give you a warning. You need to search first because they're kind of a cranky bunch over there, and they don't like you asking questions that have been answered a million times. So go over there, use the search function, read through, and if you still have questions, post up. And the eMastercam.com board is just a fantastic resource. There are a lot of people there who will help you really quickly. So it's a great resource.
What the heck? I'm going to reach out real quick. Steve, Mr. Hardmill, text me. For some reason, I can't find your number. So I know you gave me a new one. Please text me when you get a chance. Thanks. Sorry, go ahead.
No, fair enough. Okay, I got a stream of people just coming in saying thank you. Thanks for the great presentation, Micah. Thanks for the guys stepping in and helping us out with the Q&A. So I'm going to end it, guys. We're 7 minutes over time today, but this was just really was a fantastic presentation. So thank you, Micah, for that. We really appreciate it. And for Mike and Jay coming in with the color commentary, and those of you out there spending your day with us and asking questions, because it makes our job a lot easier when we have somebody to interact with. And honestly, you know, Micah in particular spends a lot of time on these presentations, although Jay and Mike also spent several hours each just helping us outline this presentation. But where the real learning takes place is when you guys are asking questions, because that's what just takes us down paths that we hadn't even thought of. So we really do appreciate your time, everybody, and to you panelists. Thank you, everybody, and we'll see you next time.